Hello everyone, today we are traveling 63 light-years away from Earth, deep into the constellation Vulpecula, to meet one of the most terrifying and awe-inspiring planets ever discovered by human astronomy. This is HD 189733b, the infamous glass rain exoplanet, a hot Jupiter that redefines what we think of as extreme weather and shows us just how violent and unforgiving the cosmos can be. In this deep dive documentary, we will explore every horrifying detail of this hellish world, how it was discovered, why it behaves the way it does, how its deadly glass storms form, what it would be like to stand on its surface if you could survive for even a split second, and what this bizarre planet teaches us about planetary formation, atmospheric physics, and the true diversity of worlds beyond our solar system. Let us start at the very beginning, the discovery of HD 189733b. It was first detected on October 5, 2005, by a team of French astronomers using the transit method, a proven technique that spots exoplanets by measuring the tiny dips in brightness when the planet passes directly in front of its host star. At the time, astronomers were thrilled to find such a well-behaved exoplanet, one that transits its star regularly and is close enough to Earth for detailed study. It orbits a K-type orange dwarf star called HD 189733AA star, slightly smaller and cooler than our Sun, but one that unleashes intense radiation and stellar wind onto its closest planetary companion. What made this planet even more special is that it is a hot Jupiter, a gas giant, similar in size and mass to Jupiter, but orbiting extremely close to its star, a configuration that was once thought impossible until the first exoplanet discoveries revolutionized astronomy. Now, let us break down the basic facts that set this planet apart from anything in our solar system. HD 189733b has a mass about 13% greater than Jupiter and a radius roughly 14% larger, making it a slightly inflated gas giant. But its orbit is where the true madness begins. This planet orbits its host star at just 0.031 astronomical units. For context, that is nearly 10 times closer than Mercury orbits the Sunday. At that distance, it completes a full orbit in only 2.2 Earth days. Think about that for a moment. One full year on HD 189733b is less than 3 of our days. The planet zooms through its orbit at a mind-blowing 152 kilometers per second, or over 340,000 miles per hour, fast enough to circle the entire Earth in just over 4 minutes. This extreme proximity to its star is the root cause of every single terrifying feature we observe on this hell world. The first catastrophic consequence of such a tight orbit is tidal locking. Just like the moon is tidally locked to Earth, with one face always facing us, HD 189733b is permanently locked to its star. One hemisphere, the day side, is constantly bathed in brutal, unrelenting stellar radiation, while the other hemisphere, the night side, spends eternity in freezing pitch-black darkness. There is no sunrise, no sunset, no gentle transition between day and night. Instead, there is a sharp, violent divide between a scorched, superheated dayside and a frigid, dark nightside, creating a temperature gradient so extreme it drives weather systems that border on science fiction. On the dayside, temperatures soar to nearly 2,000 degrees Fahrenheit, or over 1,000 degrees Celsius, hot enough to melt steel, aluminum, and most known metals. On the night side, temperatures drop to around 1,200 degrees Fahrenheit, still blisteringly hot by Earth standards, but cool enough to trigger dramatic changes in the planet's atmosphere. This massive difference in heat is what powers the most horrific weather phenomenon in the known universe, the glass rain. To understand the glass rain, we must look deep into the planet's atmosphere. For years, astronomers used the Hubble Space Telescope, the Spitzer Space Telescope, and ground-based observatories to dissect the air surrounding HD 189733b, and what they found was nothing short of astonishing. The planet's deep blue color, which makes it look so inviting, is not from oceans of water like Earth. Instead, that brilliant cobalt hue comes from high-altitude clouds, laced with tiny silicate particles that are in essence microscopic grains of glass. Silicates are the most common minerals in rocky planets, like Earth-forming rocks and sand everywhere we look. But on HD 189733b, the extreme heat vaporizes these silicate materials, turning solid rock into a gaseous mist that rises high into the atmosphere. As this silicate vapor drifts from the scorching dayside to the slightly cooler nightside, it cools down and condenses into tiny liquid glass droplets. These droplets then cluster together to form clouds. And when those clouds become heavy enough, they fall as rain, but not rain as we know it. This is rain, made of molten glass, sharp enough to slice through metal, hot enough to burn through any known material, and falling in a way no rain falls on Earth. But the horror does not stop there. The temperature difference between the day and night hemispheres does not just create glass rain, it fuels supersonic winds that make Earth's most powerful hurricanes look like gentle breezes. On HD 189733b, winds scream across the atmosphere at speeds reaching 5,400 miles per hour, or nearly 8,700 kilometers per hour. To put that in perspective, that is more than 7 times the speed of a bullet fired from a high-powered rifle, and more than twice the speed of sound in Earth's atmosphere. These winds do not just blow up and down. They blow sideways, slamming the molten glass rain horizontally across the planet at those impossible speeds. Imagine being caught in a storm where every single drop of rain is a tiny, burning shard of glass, moving fast enough to cut you to ribbons in an instant. NASA scientists have even nicknamed HD 189733b the slasher planet because any object caught in its atmosphere would face death by a million cuts from these flying glass shards. There is no shelter, no protection, no way to survive this endless violent storm. The atmosphere of HD 189733b holds more dark surprises beyond its glass storms. Astronomers have detected a long list of exotic and toxic chemicals in its air, including water vapor, carbon dioxide, carbon monoxide, sodium, potassium, and even hydrogen sulfide, the gas that gives rotten eggs their terrible smell. So not only is this planet raining, burning glass, and howling with supersonic winds, but it also smells like rotten eggs, making it a nightmare for all 5 senses. The planet's atmosphere is also constantly being stripped away by the intense stellar wind from its host star, forming a long, comet-like tail of hydrogen that stretches millions of kilometers into space. Hubble observations first spotted this evaporating atmosphere in 2007, making HD 189733b one of the first exoplanets where atmospheric escape was clearly observed. This slow erosion of its atmosphere tells us about the violent relationship between hot Jupiters and their host stars, and how even massive gas giants can be worn away over cosmic time. One of the most groundbreaking achievements in studying HD 189733b is that it became the first exoplanet to have its full global temperature map created, and the first exoplanet whose actual visible color was measured directly by Hubble. Before this, astronomers could only infer colors and temperatures based on models, but HD 189733b was close enough and bright enough to allow direct observations. That deep blue color was confirmed in 2013, stunning the scientific community and the public alike. It was a reminder that the universe is full of visual wonders, but many of those wonders are deadly and hostile to life as we know it. This planet also changed our understanding of hot Jupiter's atmospheres. Before HD 189733b, astronomers thought hot Jupiters would have simple, predictable atmospheres dominated by hydrogen and helium. But this planet showed us that hot Jupiters can have complex dynamic atmospheres with clouds, storms, chemical reactions, and even precipitation, just not the kind we would ever want to experience. Let us take a moment to imagine what it would be like to approach, and even attempt, to land on HD 189733b, even though we know it is a suicide mission. As your spacecraft draws near, you would first see the striking blue glow, shining brightly against the blackness of space, almost like a blue gem in the cosmos. You might feel a moment of wonder, thinking you have found a beautiful alien world. But as you get closer, the illusion shatters. You would see the atmosphere churning violently, with massive swirling storms stretching across thousands of kilometers. You would detect the intense heat radiating from the dayside, so strong it could fry your spacecraft's instruments from millions of kilometers away. As you enter the upper atmosphere, you would be hit instantly by the supersonic winds, shaking your craft apart before you even feel the first glass shards. If you somehow survived the winds, the molten glass rain would slice through your hull like a hot knife through butter, and the searing heat would melt whatever remained. There is no solid surface to stand on anyway. HD 189733b is a gas giant, so its atmosphere simply gets denser and hotter until it becomes a slushy layer of liquid metallic hydrogen with no firm ground to touch. The entire planet is one endless, violent burning storm, a hellscape that makes our scariest science fiction monsters look tame. You might be wondering, Why do we care so much about a deadly, uninhabitable planet 63 light-years away? The answer is simple. HD 189733b is a critical laboratory for planetary science. It pushes our models of atmospheric physics, weather formation, planetary migration, and star-planet interactions to their limits. By studying this extreme world, we learn how planets form and evolve under conditions nothing like our solar system. We learn about the behavior of gases and minerals at temperatures and pressures we cannot replicate in Earth labs. We learn how stellar radiation affects planetary atmospheres, which helps us in the search for truly habitable exoplanets. Every discovery we make on HD 189733b sharpens our tools and our knowledge, bringing us closer to answering the biggest questions in astronomy. How common are habitable worlds? How unique is Earth? Are we alone in the universe? This terrifying hell planet is not just a curiosity, it is a key that unlocks the secrets of the entire cosmos. Over the years, HD 189733b has remained one of the most studied exoplanets in history. New observations from the James Webb Space Telescope have added even more details to its story, detecting more trace chemicals, mapping its winds with higher precision, and refining our models of its gas cloud formation. Each new piece of data makes this planet more fascinating and more terrifying, showing us that nature's creativity is far wilder and more dangerous than anything we can invent. It is a humbling reminder that Earth is an incredibly rare and precious oasis, a world where waterfalls as gentle rain winds stay calm enough for life to thrive, and the temperature is perfect for liquid water and stable ecosystems. We often take our planet's kindness for granted, but when we look at worlds like HD 189733b, we see just how lucky we are to call Earth home. As we wrap up our journey to this glass rain hell planet, let us reflect on the awe and terror it inspires. The universe is full of extremes of worlds that are beautiful yet deadly, serene yet violent, mysterious yet revealing. HD 189733b stands as a symbol of the cosmos' raw, unbridled power, a world that challenges our perceptions and expands our understanding of what a planet can be. It is a testament to the brilliance of human astronomy that we can detect, study, and understand a world so far away, so different, and so dangerous. Every time we point our telescopes at the stars, we find new wonders, new horrors, and new lessons that make us smarter and more connected to the vast universe around us. Please like, comment, share, and subscribe to the channel